All right, so this is lesson 3.4 where we're going to start sketching transformations. So before we do that, let's sort of go over some of the things that we've learned already. So in this warm-up, it's asking you to state the vertex and list the transformation. So we're in vertex form. So I know that my vertex has to be at 2 and 4. So the 2 is the x value of our vertex, and then the 4 is the y value. Now, there are 4 transformations here. So the negative, that tells us there's a reflection of the x-axis. Okay, so it's flipping over the x-axis. The 3, so we learned yesterday that if a is greater than 1, that means there's going to be a vertical stretch. So it's going 3 times faster if you want to think of it like that in terms of how the y values are growing. So then we stated our vertex. So our vertex is 2, 4. So that means we are going 2 units right. And then the plus 4 on the end tells us we are going 4 units up. Okay, so hopefully that gets yesterday's information current in your brain. So today our learning goal is to be able to actually graph a new parabola by describing the transformations and use something called mapping to help us generate that new graph. Okay, so just to review once again, so that's vertex form up here. So the vertex will have the coordinate h, k. So these letters, they don't mean anything in particular other than they're placeholders. So the number inside the bracket is going to be our vertex x value, and then the k value on the outside, that is the y value. So as we learned yesterday, if a is less than 0, that means we have a reflection of the x-axis. X-axis. Okay, if it's between 0 and 1, that means we are going to have a vertical compression. And if a is greater than 1, that is a vertical stretch. R. Okay, CH. That looks bad, but it means stretch. Okay, now the K, so the number on the N, that is going to tell us if it's moving up or down. So when it's greater than 0, we are going up K units. And if it's less than 0, we're going to go down K units. So what you see with that transformation is what you get. If it's positive, we're going up. If it's negative, we're going to be going down. Now, h is greater than 0. So if h is greater than 0, that means we are moving right h units. And if it's less than 0, we are moving left h units. So this one's a little bit tricky. So if I know that I have y equals x plus 3 all squared plus 1, and I want to describe the transformations. This is the same thing as having x minus negative 3 all squared plus 1. So when it's written like that, it's easy to see that h is equal to negative 3, which means it's going to move left. However, we tend to simplify it and turn those two negatives into a positive. So just be really, really careful with that. Okay, so that's a review. Now we're going to sort of talk about what are changing. So when we're transforming, what are changing the values of x and y accordingly? So which ones are going to change the x? There's only one change to the x. So this is a shift left or right. If we're talking about the y, there can be a reflection. There's going to be a vertical stretch or compression. And then finally, there's going to be a shift up or down. So this kind of shows you that there's only one thing that can happen to the x, whereas there's 3 things that can happen with the y. All right, so let's start doing some examples. So this process that I'm going to work through, I'm going to go through 3 full-on examples. is a very procedural way of graphing the transformation of a graph. So we're going to work through 3 of them so that you can see how to deal with different situations. So the first thing we're going to do is we're going to graph y equals x squared, but I'm going to kind of do step 2 before I do that. So we want to see how the graph is changing. So I want a point that's going to be before the vertex, the actual vertex, and the point after the vertex. So if I'm looking at my base function of y equals x squared, I'm going to put the vertex in the middle. So that's at 0, 0. I'm going to pick a point before that, and then a point after. And I'm making it symmetrical because parabolas are symmetrical. So if I'm populating this table and y is equal to x squared, I know I'm going to have 4 and 4. So I'm going to plot that. Okay. So this is what my parabola looks like. Okay. So that's the original. Every single question is going to start off with this y equals x squared when we're talking about doing transformations, because it's always compared to this here. Okay, so now we're going to list our transformations. I'm just going to rewrite the equation. So we have y equals negative 2x squared. So there's 2 transformations. So this negative means that we have a reflection of the x-axis. Then the 2, that's telling us we have a vertical stretch of 2. All right, so now we're going to identify how x and y are changing. So there's no transformations done to the x, so our x is going to stay the same. The y is going to become negative 2y. So where's the negative 2 coming? That's because it's the stretch factor and the reflection. So I have to show mathematically that that transformation is occurring. Okay, so now in order to do this, I'm going to create a new table of values using the original values that I had. So the original values I had for x were negative 2, 0, and 2. I'm going to rewrite those values because nothing has happened to the x. The y, on the other hand, so in the table here, this should be negative 2y. My original value was negative 4, but I'm transforming it. So I have to multiply by negative, sorry, this was a positive 4. So I'm going to multiply by negative 2 to get negative 8. I have 0 multiplied by that negative 2 factor to get 0. And then I have 4 multiplied by negative 2 again to get negative 8. So I'm using my original points and I'm applying the transformation to them. So right away I know that my parabola should be flipped or reflected, and I know that it is going to be skinnier because it's been stretched. So I still have a point at 0, 0, but now I'm at negative 2 and negative 8 as 1, and 2 and 8. So this parabola, my hand's a little bit shaky, looks like this. So as you can see, hopefully a little bit, it has become skinnier. Okay, so let's do another one. All right, so now we have some other transformations happening. So I'm going to start the same way. I have negative 2, 0, 2. So I have 4, 0, 4. So like I said, we're always starting from the same point. Y equals x squared. All right, so that's a decent sketch. Then I'm going to list the transformation, so I'm going to rewrite my equation so I can see it. So I have y equals x minus 1 squared. I believe it's plus 3. Yep, plus 3. So once again, we have 2 transformations. So it's going to shift left 1 unit, and it's going to shift up 3 units. Okay, so we have those shifts. So now we're going to say how our equation is going to change. So if I'm moving, oops, I made a mistake up here. It's not going to be left. It's going to be right. And that's because the vertex for this graph should be at 1 and 3. Okay, so if we're shifting right, x is going to become x plus 1. Every single x value that I started with needs to move to the right, so I get x plus 1. For the y, we're going to get y plus 3 because we're moving down. Up 3 units. So my original x was negative 2. I'm going to add 1. So now I'm at negative 1. I was at 0. I'm going to add 1. I get 1. Then I'm at positive 2 plus 1. So now I'm at 3. I'm going to do the same thing with the y values. We were at 4. I'm going to add 3 to get 7. We were at 0. Add 3 to get 3. 4 once again, plus 3 to get 7. So this point in the middle, the 0, 0 being transformed, will always be our vertex. So now I'm able to graph. So I'm at negative 1 and 7. I'm at 1 and 3. And I'm at 3 and 7. So this parabola is it's congruent to the one that we started off with. It's the exact same shape. However, it's been shifted to the right 1 and up 3. Okay, so hopefully that makes sense. So I'm using this new table to get the new points and then plot them. All right, so the last example we're going to work through is this one right here. Now this one right here, when I look at it, I see a fraction, and I see that that fraction is a 3. So instead of using the 2 value this time, I'm actually going to use the 3. And the reason why I'm going to do that is because it'll make the math a little bit easier. So when I square 3, I get 9. 0 is still 0. Positive 3 is going to give me 9. So at negative 3, I'm at 9. I still technically have this point at negative 2, 4. I have 0, 0, 2, 4, and 3, 9. I didn't include those in my table, but they're still there. Okay, so that's a decent enough parabola that I am working with right now. So then, when I'm looking at what's happening right here, I have my equations. So I'm just going to rewrite my equation right here. Okay, so I can see it. So now we're going to list the transformations. So this one right here, we have all 4 transformations. So I have a reflection of the x-axis. I have a vertical compression of 1 over 3. I am going to shift left 2 units, and we are going to shift down 2 units. So now I'm going to translate that into equations. So the x has been transformed this time. So x this time, because I'm moving to the left, is going to be x minus x. The y, I have to reflect it. I have to compress it. So that's why I'm going to multiply by negative 1/2. So think of bed mass. We always do multiplication before we do addition and subtraction. And then I have to subtract 2. So that's what my new table is going to be structured from. So I have x minus 1 and negative 1/2 y minus 2. So I did have negative 3. I'm going to subtract 1. So that gives me negative 4. 0, subtract, wait, no, I think I made a mistake. It's not 1, it's 2. I don't have anybody in front of me to correct me. So I'm just going to quickly go back and fix these little equations so that it works. Okay. So it's x minus 2, x minus 2. So this becomes negative 3 minus 2, which is going to be negative 5. So I'm going to do the x column first. 0 minus 2 is going to be negative 2. and then 3 minus 2 is going to be 1. All right, so the original y that we had, oh, I see another little mistake. All right, so this should not be a half. It should be a third. That's why I picked the 9 in the first place. So I have negative 1 over 3 multiplied by 9, because I'm taking that original value. That looks like an A, not a 9. So I have multiplied by 9, subtract 2. So negative 3 multiplied by 9 is negative 3 minus 2. So that equals negative 5. And here I'm going to have minus 2, because we'll have negative 1 over 3 multiplied by 0 minus 2, which equals negative 2. And then this one is going to give me negative 5 again. So now that I've changed those points, I can now plot them. So I have a point at negative 5, negative 5. So negative 5, negative 5. I have a point at negative 2, negative 2. And I have a point at 1 and negative 5. So I'm going to draw that parabola. So it's definitely been reflected. It's definitely been compressed because it's a little bit wider. And then the vertex is now at negative 2, negative 2. So that's basically how we can use a process to transform our equations. Hopefully it makes sense. If not, please come see me and ask questions.